here's a circuit problem. It's a little different circuit though, because this circuit contains an inductor as well as a resistor. So as usual for a diagram for this one, we need a diagram which says that we have a battery that looks like so, some wires, and here's a switch. The switch is now open, so that when the switch is open, of course, there's no current flowing. And what else is happening? We have an inductor. The inductor symbol looks like this. Inductors are often coils, and so that's why that symbol is that way. Then there's a resistor, which looks kind of frictional like so. And then finally the return path along wires to the battery. So now what does it tell us? Battery is 9 volts. It tells us that the inductor is 200 millihenries. And that the resistor is 6 ohms. Okay, what is it that happens when the switch is closed? Current begins to flow out of the battery when the switch is closed. It's not flowing now, but I just draw it as if it is. Okay, current flows through this inductor. What happens when it flows through the inductor? Well, the inductor doesn't like the current to be flowing. It likes the status quo. And so the result of that is it slows down the current. So the current doesn't really actually reach its peak for quite a while. In fact, rather than just playing the circuit diagram, maybe we're better off if we draw not only this, but a graph that shows how the current grows with time. I as a function of time. In this kind of a circuit is one where it starts out at 0 and then grows until exponentially it starts to approach what's called Imax. And what that means is after a long time, it's as if the inductor isn't there. The inductor just becomes more wires, and so the current flows through it, and that's it. Great. So this is what they refer to as an LR circuit. Since it has both things in it, the way the LR circuit works is that I, the current that flows, equals I max times a wonderful little mathematical thing here that says 1 minus e to the minus t divided by L over R. Complicated little expression, but such is life. So now do we know what this stuff is? Well, we know T, we know L and R. What's Imax? How do you get Imax? Well, Imax occurs when, for all practical purposes, there's just nothing left but a resistor. And so Imax is equal to V over R. So we know what Imax is. It's 9 volts divided by 6 amps. 9 volts divided by 6 ohms. And so this is 1.5 amps. So that's Imax. So now we can put that all in and say I equals this 1.5 amps multiplied by 1 minus e to the minus. Now it says T here is 50 microseconds. So this is 50 times 10 to the minus 6 seconds divided by L over R. And L and R are 200 times 10 to the minus 3 henries divided by R, which is 6 ohms. So that's a complicated little expression. You get to work your calculator a little bit to make sure that that all turns out to be fine. And the result of all this is 2.25 times 10 to the minus 3 amps. So eventually it's going to get to 1.5 amps, but now after the relatively short time period, 500 microseconds, then all that's flowing is this 10 to the minus 3 amps. So it starts off slowly and builds, and eventually works its way up to Imax. Okay, that's the LR circuit.